everybody, welcome back to my YT channel. This is again, I'm a singer, Eternal Voice. So let's go back to our main topic. But before going further, I have here specific problem solving regarding thermochemical equation. By the way, before proceeding with this kind of problem solving, I need to discuss first what is really a thermochemical equation. Okay, so thermochemical equation is basically a balanced chemical equation. Remember, balanced chemical equation that involves enthalpy change of reaction or heat of formation of the reaction. Okay, something like that, meaning thermo, heat, H-E-A-T. Okay, so the topic of thermodynamics, thermochemistry is really related to this particular topic. But in here, we are talking mainly of equations. Okay, balanced chemical equations. But the other problems in thermodynamics, not necessarily on chemical equations. Okay, probably initial state, final state, but doesn't mix all the time with chemical reaction. But thermochemical equation is always balanced chemical equation. Get the point? Okay. More na siya ang difference. Okay. Okay, take note with our problem mga palangga. Okay. Can you see it? Oh, it's very small, right? Okay, zoom in. Oh my gosh. Kana, kita na no. Oh, diba? Kaloka. Kita na siya. Di mo okay. Kana, diba? Propane reacts with oxygen gas in a combustion process. It was mentioned that it's combustion. Okay? How much, letter A, how much energy in kilojoules will be released if 500 kilogram of propane is burned in air? It looks like difficult, right? Okay. B, how many kilograms of propane is needed to generate, this is generate guys, I forgot, generate 500 megajoules of energy if the process is 40% efficient. Nakakaloka. Okay? You get the point. So, this is combustion process. Since we don't have chemical equation, the problem doesn't specify the equation in the question. Okay, so this is only natural because some questions are not having chemical equation or chemical reaction. You have to do it by yourself. So in this case, the products also are not being discussed. It's only state combustion process. So it is understood to be that the students or examiners knows what are the products of combustion process. So that's make this difficult. Okay, if we don't attach the theory and principle, then we don't know, or we don't know really the products are. Okay, because the problem or the paragraph doesn't specify the products. Okay, then if you know it, then bingo, perfect, you can solve the chemical equation, but it's up to you how to manipulate the solution proper. Okay, like that. You can solve it usually. Thermochemical equations can be used usually by using dimensional analysis conversion way of solving the problem, not the standard formulas and equations to be used. Okay, like that. Okay, no standards formulas to be memorized. Always, conversion like that, blah blah blah, so para-paraan in order you can solve the answer. So I just call it a para-paraan way of solving, meaning there's no specific standards formulas to be used or equations to be used. So this is the difficult thing in pure sciences, things like this. Okay, but sometimes also you can use the equation standard, but sometimes no really standards to use that. Okay, let's check also if we can. Okay? It depends sa really talaga siya on the situation. Okay? So, combustion of propane. So, in fact, propane is also word here. Okay, what is the formula of propane? Okay, 3 atoms of carbon. Then substitute that in the formula of hydrocarbon, CnH2n plus 2. Right? If you don't know really the formula of this propane, then substitute the N, which is the 3 atoms, in CnH2n plus 2, because that is the A and E family, propane. Then if you know already the formula, then perfect. Just have it directly. Okay, C3H8. Okay, 3 atoms of carbon. Because we memorize this every time since first year college to fifth year college. So we don't need to have the formula again, right? But for the sake for others who are not yet familiar for this, you can use Cn H2n plus 2. N, 2n are the subscripts. Like this, Cn H2n plus 2. Then substitute the value of n, which is 3. Then bingo, you can solve C3H8 here. I don't have to emphasize because it's direct substitution. Okay? So propane, ganon. Propane, okay, gas plus oxygen gas. Sometimes also guys, in problem solving, if they mean with air, that would mean oxygen gas. Why? Because they have the concepts that oxygen is really reactive in the atmosphere, not the nitrogen. Since nitrogen is a noble gas, meaning to say non-reactive or inert gas, so it is not reactive. Usually, oxygen will be considered as an air. What I mean, the oxygen will not be mentioned. The word AIR will be mentioned on the problem. So you will also be confused. What is the air? So that means oxygen diretso. Was the pagway duha-duha. Okay, if there's no other gases being mentioned. Okay? Get the point? So it's not nitrogen, though we understand that our atmosphere contains 79% by volume of nitrogen. We know that technically, but it is not the way it is being adapted to your science. It should be the oxygen will be our air. Okay? Unless not specified. If specified, then we will be happy because it's specified. But if not, that is automatically air. AIR represents oxygen. Siya yung makaangkon. You get the point? Okay. So, C3H. So, what I mean, if the problem will say propane reacts with air in a combustion process, that would mean also propane reacts with oxygen. You get the point? Okay. So, propane plus oxygen gas. What I mean, not necessarily nga magpaabot dito sa oxygen. Okay? Para lang tamo proceed sa atong solution or equation. Put that in our brains as that an air also is an oxygen unless specified. The other gases na dili wala man. Pugsod jud dato. So air will be oxygen gas, okay? Like that. So propane plus oxygen gas is equals to combustion process. The products are carbon dioxide, the greenhouse gases, okay? Like that. Plus, okay, water. Our water will be vaporized, vaporization into the atmosphere. It's also gas. Okay? Like that. So perfect, all gases, huh? Okay? Get the point. Okay, question letter A. Wow. If 500 kilograms of propane is burned in air, see? Burned in air, and we add oxygen. Meaning to say, oxygen gas is an air. Okay, technically. So, how many kilograms of propane is needed? Okay? Like that. If 500 kilograms of propane is burned in air, okay, A, how many kilograms of propane is needed to generate 500 millijoules of energy if the process is 40% efficient? Okay. Okay. So the first is how many energy will be released if 500 kilograms of propane is burned. In fact, it doesn't specify heat also. You're crazy, right? Questions like this are very, very crazy. Okay, it doesn't specify its heat, but it's normally understood in this kind of problem, especially burning, or see, burn, okay, like that, or adding oxygen, adding air. Usually that is heat, H-E-A-T. So, meaning to say, if you try to say this in a precise and appropriate manner, the letter A will be how much heat energy kilojoules will be released. But sad fact, sometimes they don't put heat. Okay, that's why other students or other examiners will be confused because there's also other energies such as internal energy, okay, enthalpy, like that. Those are energies also. Okay, so magpaabot dito sa yung technical term, then nga. So that we should analyze the whole scenario of the problem that it involves heat, because this is combustion, so automatically that involves enthalpy change of reaction, ganon. Heat of reaction, heat of formation of reaction, matik na siya. Okay, you get the point. Okay. So, letter A will be like that. And then in this kind of problem, guys, the general way of solving will be like this. We start with grams, then arrow to number of moles, then arrow to heat energy. You need to draw a flow chart for your solution. Your step 1 from grams, step 2 convert to number of moles, step 3 get the number of moles as stoichiometric relation, and bingo, we can solve for the heat. Okay, like that. So, or it could be the reverse: heat first, going to the number of moles, going to the grams, or heat going to the grams. It depends, but you know the process really what you're going, huh? So that you know where you are going to, just like a destination. When you travel to different places, you know where you are going. Okay, it's just like also the problem solving. You know you are going. What destination is that? Your destination will be to compute for the heat. Okay, and then you start with the mass as your starting point or your starting location. Like that. I'm just explaining in so that we can understand further, okay? Like that. So, it's gonna be like that, okay? So, kailangan tayo 500 kilogram, this follow this general flow chart. So, gram na siya, di ba? Okay. 500 kilogram. Okay. 500 kilogram. We are using now the dimensional analysis of solving the heat energy in kilojoules. Like that. So, 500 kilograms of propane, mga palangga. So, it is propane, C3H8. Okay. Since you are starting with the automatic, what comes in our brain cells are the molar masses and the molecular weight. Maugid na siya per me. Basta stoichiometric chemical calculations, like that, involve chemical reaction. Molar mass, molecular mass play an important role to compute what is being required. Okay? Get the point? So since that is kilogram, then we need to convert that to grams because the unit of the molecular weight or the molar mass are in terms of grams per mole. Okay, something like that. So it will be checking the compatibility issues of the units of measurements. Okay, like that. So 1 kilogram of propane, okay, like that, is equals to 1,000 grams of propane. Oh, ganon. So, cancel kilogram. You get the point? And then, we have now the grams. So, go to the step 2, which is the number of moles. Right? Multiply that with the molecular weight. But, adjust. If the grams will be cancelled with the molecular weight, then you have to flip the molecular weight to cancel the grams, or reverse just to cancel the denominator and the numerator, things like that in algebra. Okay, like that, math. Again, math. Okay, so 1,000 grams of propane. So since we have the molecular weight of propane, the molecular weight of propane is not given also in the problem. We will be the one to compute. Okay, so it's gonna be 3, and then you will also know the atomic weight. So that's why I advise you guys, if you are still in the lower level, okay, memorize the basic and common molecular weights and atomic weights to those substances that are mostly explained, mostly mentioned, mostly present in the sample problems, because so that you will not be tired of seeking the the tables or whatever, the periodic element like that, especially in classroom instruction, examination and prelims, midterms, and finals. You don't have to open the book. Okay, so like that, unless your teacher will say, oh, you're allowed to bring the periodic table. Perfect. I can see the atomic weight, the atomic mass, the atomic number, the mass number, the electrons, the protons, something like that in the periodic table. Okay? Like that. So you memorize the common. For the carbon, what is the atomic weight or atomic mass of carbon? Okay, that is 12. 12 grams per atom. Okay? Why atom? Because this is only single element. Okay, like that. And then we have hydrogen. O, ganun, 1.008 grams per atom. Okay, like that. You get the point? And then 3 atoms. Okay, so 3 times 12. Ganon. So 36. Okay, since you multiply that already, it will become now the mole. Okay, so 36. Okay, 36, then 1.008 times 8 mga palangga. So, memorize ko na ko ang molecular weight sa water. Okay? So, sige lang. So, 1.008 times 8. Kaya 8 ba ng propane? Ganon. Calculator, please. Dapat. Wala mga palangga. Ang calculator ba? Wala ka nabili, Jude. Charach. Okay, here it is, mga palangga. So 8, because 8 is a subscript of hydrogen. So 8 times 1.008, meaning subscript times the atomic mass or the atomic weight. Okay, atomic weight and atomic mass is just the same. Okay, 8.064. Oh, ganon. Okay. Then 36 man siya. So 36 plus 36. Okay. 44.064 ang propane. Really? Ito ka. 3 times 2. Review na to kay may pareha siya sa carbon dioxide. I doubt. Okay. Kaya carbon dioxide, I think mga 40 plus, then I doubt something like that. So 1 times 1.008 times ganon equals to plus 36 chuba chuchu. Really, 4.064 grams of this propane and then mole in the top. So that to cancel. Cancels gram, tadadat, tadadat. Oh, what is being left is the number of moles. Okay, so our number of moles will be on the top. Now, step number 3. We're still in the number of moles. Okay. Now, look at the stoichiometric relationship. Okay, so it is balanced or not? This is the problem. You will always look at it if it's balanced or not. And if it's not balanced, do not proceed your calculation. You will be entirely wrong. Okay, proceed the balancing of chemical equation. Okay, atoms in the left of carbon is 3. Okay, ganun siya, chuba-chuchu. Okay, 3. We will just be using the, trial and error method of balancing the equation because there's no enough space in my whiteboard. I cannot do the mathematical way of solving the atoms. Okay, like that. So 3 atoms, trial and error method lang. Okay, 3. Ganon. So hydrogen 8. Okay, times 4. Ganon. Okay, then oxygen, so 6 plus 4, 10. So therefore, we conclude 5 will be the moles of oxygen gas. Review, second review. Carbon 3, hydrogen 8, oxygen 10, 6 plus 4, 10. Perfect! Our combustion process of propane has been balanced completely. Now we proceed back to our dimensional analysis of computation. Okay. This is mole of propane, and look at it in the chemical reaction. Then the mole of propane will be in the denominator. So check here, the propane. So the propane has only 1 mole, okay, in the beside. The mole is expressed beside the element and the compound. Okay, that's very clear. Okay, 1 mole, okay, C3H8, ganon. Then, what is our relationship for that? We don't go for the other element relationship because we are asking for the energy. See, energy. Okay, you get the point? Energy, and our delta H will be, our delta H here. Okay, our problem, guys, needs delta H. Because this is thermochemical equation. There must be an enthalpy change of the reaction, and then you get the point, and heat of the reaction, heat formation of the reaction, nakakaloka. Okay, so delta H is negative, let's say, hypothetical lang siya guys ha, because you know, I forgot to write the delta H. Okay, like that. Anyway, even though how much you put or any number you put, if you understand really the problem, it doesn't matter. Okay, like that, because we are not referring always to reality. You can use hypothetical as long as you understand, you can solve the problem completely. So let's assume that our delta H is negative, because we have delta H of methane combustion. I memorized that also, negative 890.4 kilojoules. So let's just assume that our propane will be times 3. Oh no, because that's methane times 3, mga ano siya, 890 times 3, mga okay, charot. 720 kilojoules. Okay? Why I do this? I do this mga palangga because in this reaction, I have also 1 mole of propane. And then if I choose methane also in the combustion, there is also 1 methane, something like that. And then if you try to do the ratio and proportion, that's why it's easy to say, times 3 the delta H. Ganon. So, negative 720 because the heat is released from the system to the surrounding. Ganon. So, meaning to say, the heat is absorbed by the surrounding. Okay. Makalibog ko sa'yo, no? Okay. So, I will say, this is negative because the heat is released to the surrounding from the system. Or the heat is absorbed by the surrounding from the system. So, preposition is very important, right? From, to, by, with, on, like that. Very important in thermodynamics and thermochemistry and thermochemical equations, the terms, the preposition or conjunction in English. Okay, like that. So since we have 1 mole of propane, take a look here mga palangga, only 1, right? Then put the numerator, in the numerator, negative 720 kilojoules. Ganon. Guys, I refer to the solution. Another problem, this is not a problem. When I watch also the video of, one video clip of the Harvard University Chemistry Department, okay, we have example there. We have another approach of solving, but it's the same thing. I will teach you. Okay? One of my references, University of Michigan, like that, Harvard University. I always look in their videos also. Okay? Mga ano dyan lang, mga US yun akong sources. Charot! Mga kaloka lang. Okay? Panhirapan ko yung sarili ko. Charot. So, mole of propane. Ganon. So, sometimes also University of Cambridge. Okay. Ako lang isagol-sagol. Ganon. So, 720 times 1,000 chuba-chuchu is equal to times 500 divided by 44. Ganon. So we have 8,181,818 kilojoules. Okay, like that. Okay? So if you think that is very high value, okay, then you must review again. Okay, 500 kilogram, 1 kilogram, 1,000 gram, gano'n, chuba-chucho, 44 gram mo, 1 mole, it's really correct. Okay, so this is gonna be a huge heat released to the surrounding, right? 720 times 500 times 1,000, ganon. Okay, divided by 44.06 for module siya, guys. Okay, 8.2 lang siya. 8.2 raised times 10 raised to the power 1, 2, 3, 4, 5, 6. Raised to the power 6. So this is megajoules. Okay? Because 10 to the 6 magiging siya. So 0.26 times 10 to the 6. Okay? Like this. But take note, this is already kilojoules. We will just put also the kilojoules here. Okay? we know, even though we know that 10 to the 60 megajoules, so we should not refer this one. Okay? We will refer the kg only, and we need to write all the figure. Okay? You get the point? Because mulubog siya. Okay? So like that, 8.2 times 10 to the 6 ang answer niya. Okay, guys? Now, yung aning ganit, guys, yung question. So, follow-up question. What will be the heat energy needed of the air? Okay, in a combustion process. So, same story, like this, but you will go directly to the number of moles because there's no given of the grams of oxygen, right? Nothing, right? So, you will say 5 moles of oxygen gas, like that, then you know the heat. Okay, ganon. So, the formula of delta H, or the formation reaction, will be heat over the number of moles. So, you will just divide. Okay, like that. Divide the negative 720 kilojoules to 5. Okay, it's not the 8.2, because the 8.2 is if you have 500 kilograms. But for the normal process in this reaction, oxygen is another gas. Don't carry the grams of propane. You get the point? Muna siya may tabo. So basically pala, kung wala siyang grams ihatag ang mo, if there's no grams or mass given by propane, you will also use the same thing with oxygen. Like that, negative 720 kilojoules per mole or negative 720 lang yun siya. But ihatag mo siya grams. So mausap ang imo, it will change your answer. Okay? Like that. Letter D, mga palangga. How many kilograms of propane mass na puntan? Okay, balinan niyo siya. So, reverse. We have the heat. Flow chart first. Heat. Okay, then it's gonna be like moles, 2 grams. Okay? Have the flow chart first how to solve. Okay? So, heat first. So, we have, analyze the problem. How many kilograms of propane is needed to generate 500 megajoules of energy if the process is 40% efficient? What do you mean by 40% efficient? Review physics. Percentage efficiency is equals to work output over work input times 100. And then also review chemistry part of percentage yield. Because yield is also product. Meaning to say, if you produce a product, efficiency. Okay, performance of your machine, performance of your chemical reaction. It's gonna be percentage yield is equal to the actual percentage over the theoretical percentage times 100. Ganon. So, so it's gonna be like this. If we draw a process like a square, right? So, mo mo siya sa unit operations. Let's assume that this is for example, evaporator, exchanger, or ano ba, mga units, mga of the processes. That's why it's called unit operation because units means the equipment used or the work equipment. Okay, like that. So, unit meaning this is, for example, this is just, as natong ihatag tank lang. Okay, tank, vessel, so, ganahan po tank. Char! So, this is a rectangular tank. Charot. Okay, now in a rectangular tank, charot. Okay, your feed will be the propane and the oxygen gas air. Okay? Like that. And now, the process is 40% efficient. So, meaning to say, 0.40 na siya daan, mga palangga. Okay, ang 40%. Now, percentage efficiency is equals to work output over work input. Okay. Or actual yield or theoretical yield. It's just the same, guys, okay? Like that. So, in here, we have 40% efficient, no problem. So, generate 5 mg of energy. Generate meaning this is output, right? Because the word generate, produce, given up, propagate, resulted to, like that, are all the same meaning. Okay? Resulted to, generate, given up, produce, like that, resulted to. Okay, this is generate, meaning product or output. Okay, so your product or output is 5 mg, millijoules. So, we do the overall material balance. That's what I told you. Okay, Imagine the unit operation is very far from chemistry, but you have to apply the unit operation in chemistry. At the same time, you apply also the physics, the efficiency thing, and the mechanical energy, percentage mechanical energy siya sa physics of work equipment, of any machines. Okay? Like that. So, our product will be 5 mg. O ganon. Assuming there will be no recovery and loss of energy in the process. So, 0. Okay, because it will affect if you have that, then you have recovery, right? So it's gonna be like ano lang siya. Input is equals to output without any loss or wastage in the environment or in the atmosphere. So we have a perfect OMB lang. Okay, overall material balance. Assume 0 yung wastage. Okay, so it's gonna be like input, output, ganon. So output will be your work output, of course, common sense. Input will be work input, common sense also. And you have the efficiency, so 0.40, ganon. Is equals to work output, idihatag naman ang 5 mg, ibutang na yun. So 5 mg. And then your work input is nothing. I have nothing, nothing, nothing. Ganon. So input is unknown. Solve for the input because it's being asked, see, how many kilograms of propane is needed to generate energy if the process is 40% efficient. So your work input will be your basis of calculation to compute the grams of propane needed to be burned in oxygen to produce a 40% efficient combustion process. Okay, then that's very clear. Any questions so far? Okay. Like that. So, calculator please. This is again basic math. Okay. So, it's gonna be 5 mg nakakaloka. So, we need to make this really mega. Okay. 5 times 10 to the 6 joules. Okay. Mega joules man siya. So, usually, guys, energy generation, electricity generation are expressed in megawatts, kilowatts, like that in electricity. Okay, power source electricity expressed. Okay, energy distribution in your room, you can compute how many you consume in a daily ala tool or in monthly consumption of your electrical billing. So expressed in megawatts, kilowatts, like that. So the same thing here, mega. Okay, ganon. Okay, so it's gonna be 5 divided by 0.4 mga palangga. Okay. So we have 12.5 megajoules. So 12.5 megajoules is your work input in your combustion process. Something like that. Use this as your basis of the calculation. Then start with 12.5 mg. Ganon. Hit the start then. Okay. What's next? 12.5 mg. And then over the... Now take note. If this is energy, your denominator also to be multiplied is energy. So we have delta H that I told you, which is negative 720 kilojoules. So put that in the denominator. Okay, but it doesn't match the unit. Kilojoules and megajoules. So there's no compatibility. So convert that all in joules. Okay, so times 10 to the 6 joules. Okay, and then we have also negative 720 kilojoules, so 750,000 joules. Okay, so joules cancel, chuba, chuchu, ganon. And that is for how many kilograms of propane gapon siya. So propane, butangi o propane. Okay, propane. Ganon. Get the point? So, ang propane is 1 mol gihapon. Okay? Guys, you will never put the grams, guys, in the numerator because joules and the grams, energy and the grams are not really compatible in as a ratio. It's always the mole and the heat. Magkuyog siya during the cancellation, whatever like this. Okay, we have the joules. Like this, you don't have to put the gram of propane in the numerator. Why? Because that is not compatible with each other. It's always the number of mole. Because the theory of the enthalpy heat of formation, that is, in every mole of like this, it will have an energy like this. So it's not in the theory that says in every gram of like this, it will produce enthalpy heat of reaction or heat of reaction of kilojoules like this. It's always mole, mole, chuba, chu, chu. Okay, so that's why we cannot put the grams here in the numerator. It's always the mole of propane in which 1 mole in the stoichiometric relationship. Ganon. So we have now the mole in the upper portion, and then you need to convert that to grams. Then again, molar mass, molecular weight. So in short, put that in your brain cells. If it asks for the grams, it will connect to the molar mass or the molecular weight. Then if it asks to the heat energy, it will connect to the number of moles. Okay? Do not mix up like that. Okay? Problem. Okay, so I need to erase some of this writings here because it will create confusion. Charots. Okay, so 1 mole of C3H8. Oh, ganon. So, use the molecular weight of propane again. So, 44.06. Okay, grams sa taas, mole lang was to cancel the mole. So, mole. And then 44.06 grams. So, cancel, chuba, chu, chu. So, we have now grams. Okay, so, taas kayo siya mga palangga. 12.5 exponent to the 6 times 44.06 divided by 720,000. Okay, right? Okay, like that. Okay, pila man siya? 764. Okay, 764 siya. Okay, so since you are doubting your answer, again, you have to repeat. It's gonna be the process like that, of course. Okay, times 44.06 divided by 720. Okay, your answer will be 764. Oh my gosh, mga palangga. 764.93 joules. And this is negative, meaning the heat released of the propane to the surrounding. Okay, so it's gonna be like that. If heat is released to the surrounding, so it's gonna be, you have an open system. Okay, like, because you know, in studying thermochemistry or thermodynamics related to chemistry, you have to understand the different types of systems. You have the closed system. For example, you close the tank, so the reaction inside the tank will not be the same if you open the tank. Okay, you got a point, because there's an interaction of other gases in the atmosphere and also other, you know, chemical solvents that will drop there, the rain or whatever, like that, or other impurities or residues that will try to react. But if you try to close your tank, it's gonna be like that. There's no other reaction of different substances at all. It's gonna be the energy are exchanging only there, not the matter in a closed system. Okay, you get the point. And the surrounding always your vessel, something like that. You get the point? Ganon. So you should understand the isolated system, the open system, and the closed system. Okay, so matter diha ang reaction. You get the point? Because normally if you heat something and there's no opening, okay, there will be a constant heat inside the tank. But if you open, of course, it will release the heat to the atmosphere. So the heat absorbed of the substances inside the tank will be lesser. Common sense, right? So of course, it will vary your computation. Okay. So this is assuming to be, I think so, open, little bit open. Nakakaloka. Diba? So negative 764.93 joules is the answer. Right? For this. Any questions so far? Okay. Nothing? I have nothing. Okay. Thank you so much for listening to this quick and on-the-spot vlog regarding thermochemical equations. If you like this video, you can comment, you can share, or what else, or whatever you want to do. It would be okay for me. If you are not subscribing my channel, then you can subscribe also if you want. And then click the notification bell for some newest updates of I'm a Singer, eternal voice. Bye bye, God bless everybody. Kaloka. Erase.